So I've had some free time recently, and I continued working on the data structure visualization system that I started work on a couple of years ago. The idea behind it is to create a simple way of monitoring the state of your program at a comprehensible level of abstraction. I'm most interested in the level of data structures themselves. So the first new feature is trees, and here we have some code that's just creating nodes, adding them to the root, and there's a subtree that's detached, reattached. And the code that was written is just like you'd ordinarily write for a tree, and it's automatically going to generate this visualization for you. So, and then you can do things like step backwards and forwards through the operations, or jump to arbitrary points in time. This is a similar kind of thing, except this is just going to be a random tree. We add 25 nodes at random places, and then detach and reattach subtrees to random locations. And the idea is the same with all of them, where that's just an algorithm that you would write. Like if you're writing an algorithm that builds random trees, then you get this automatic visualization of whatever your algorithm is just by writing it on a monitored node. Well, that's one way of hooking into the system, though, is you would your node class would subclass the monitored node class. Okay, so this is showing what it would look like if you have much more data. So this was 500 nodes, same algorithm is being applied. And of course you can no longer see the textual content, but as programmers we're familiar with this idea of like different things are valuable at different levels of abstraction. So the idea is to be able to look at your data at multiple levels of abstraction. So we can see large structural features when we zoom out, and that sort of guides us to regions that are potentially of interest, and then we can jump in and inspect more closely as the situation calls for it. Okay, so this is the feature that I'm actually most excited about coming up next. So instead of working with particular data structure types, instead you just have a single line command for monitoring arbitrary objects. And what the system is going to do is map all the properties on that object and any sub-objects or referenced objects. And it's going to set up something like watch points on every property. So if any property on this object updates, then you see like the live evolution of those properties updating. And you see these structural changes too. So if it's not just a single value, but a whole object is replaced, then you would see that as a subtree moving around in this kind of visual dynamic way that we've seen in the earlier demos. And this is kind of a work in progress at the moment, so I'm just showing like snapshotting a single state of these objects. I'm doing the same kind of thing here. I'm just looking at an array list this time, but it could be any, at the moment just Java objects, but the system is actually language independent. I've just written a client in Java so far, but a client could be written in whatever language you like, and you have these same rich visualization features. Okay, so this section's more about scene management, about how the system deals with having a bunch of data structures that you're monitoring at the same time. So like, how do you select from this aggregate which one in order to get more detailed information about it? And what happens if you have enough data that it doesn't all fit on a single screen at the same time? And this used to be much more of an emphasis of the project, and I think that potentially at some point in the future it would be interesting to return to have useful indications of relationships between data structures. But for the moment it's just kind of like the minimal thing to make things work. I'm much more interested in useful visualizations of single data structures. And that could either be for educational purposes or for debugging purposes. I think it's a useful system for either of those. So this last feature is, it offers the ability to color subregions of data structures. So in this case, we're going to be coloring some interesting features during a quicksort. The features are the subregion that it's operating on and the pivot. And it's possible to sort of stack up colors on these regions, which is why the push-pop terminology is used. And the reason for it, in the case of the quicksort, is that the pivot is on top of this subregion that's being operated on, and it just ends up being simpler to use this stacking metaphor in order to manage which parts are colored at a given point in time. And that is about it. Thanks for watching.